Hello everyone, myself Devashish Das, Assistant Professor of Electronics Communication Engineering Department of Greater Kolkata College of Engineering and Management. In this video, we are going to study about the different topics of analog electronics and its applications, how the analog electronics apply in our different fields of electronics. In this video we are going to study about it, different circuits and its part we are explaining one by one in this topic. Analog Electronics 1. This course is mainly for diploma students of electronics and telecommunication engineering of third semester. The paper code is PTCE AE1S3. Hello, welcome to another session of my video lecture. In this session, we are going to cover up the following topics: the concept of DC load line, the transistor load line analysis, the load line graph, and Q point. So, we are going to discuss all of this topic one by one. So, let us begin. First, we are going to discuss about the concept of DC load line. The operating condition of a transistor are determined by the following two characteristics. First, the VCE, the collector to emitter voltage, and IC, that means it is the collector current of the transistor. So these two parameters are very well required for analysis of a DC load line. So let us see the transistor load line analysis. In transistor, the circuit analysis is necessary to determine collector current for various VCE, that means emitter to collector voltage. One method is we can determine the collector current at any discrete desired VCE voltage, that means the collector to emitter voltage from the output characteristics. More conveniently, we can use load line analysis to determine operating point. Transistor load line analysis. This is a very important picture to analyze DC load line analysis. Consider a common emitter configurations. That means it is a common emitter configurations of a transistor. That means the emitter of the transistor, there are three terminals of a transistor: the emitter, the base, and the collector. The emitter terminal of the transistor, it is the NPN transistor. That means the arrow is in outer side of the transistor, so it is the NPN transistor, and this emitter is common for input and output. So that is why it is called the common emitter configuration of the transistor. So for the common emitter configuration is shown, there is no input signal. Here did not apply any input signal. Apply KVL, that means the Kirchhoff voltage law. Here we apply a Kirchhoff voltage law at the output of the circuit. That means in this loop we are applying a KVL, Kirchhoff voltage law, and we can determine it like this. If it is the voltage across VCE, that means the collector to emitter voltage. If VCE is the collector to emitter voltage, then VCE equal to the VCC minus IC RC. IC means the current through the collector, and this current IC is flowing through this resistance RC, So the voltage drop across this resistance is nothing but the IC into RC. That is the voltage drop across this resistance. So the total voltage drop, this total voltage drop equal to this plus this. So if we find this voltage, so it is VCC minus this voltage, and this voltage is nothing but the IC into RC. So in this way we determine this output expression with the help of the Kirchhoff's voltage law, and we can find this expression from the output loop of this circuit. So when the collector current, it is the output equation, when the collector current IC equal to 0, that means when there is a no current flow through this resistance, then the collector to emitter voltage is maximum. So the collector to emitter voltage is maximum and equal to VCC. That means if I put these equations VCC minus ICR and put IC equal to 0, so that this term is going to 0, and we can get only the VCC. Here we can get the VCC as this term is 0 due to the IC equal to 0. So as the IC equal to 0, and this term is going to vanish, and we can get only VCE as VCC. So when IC equal to 0, we can get the VCC as in case of VCE. When the collector to emitter voltage, that means VCE equal to 0. That means if this voltage equal to 0, we take two conditions. One condition when IC equal to 0, that means when there is no collector current flowing. At that time the voltage across the collector to emitter is VCC, and when the voltage across the collector to emitter, that means VCE equal to 0, at that time the equations look like something like this. This is the equations. We put VCE as 0, and we can get VCC minus IC RC, and we can get the maximum current at maximum IC equal to VCC by RC. So it is the maximum current flowing through the circuit, and if the current is 0, IC equal to 0, then the voltage drop across the collector to emitter is VCC. So these two are the major cases for this DC analysis of a transistor in common emitter configuration. So in this way we can find out a graphical representation of IC versus VCE, and we can get 2-point VCC and VCC by RC, which is the maximum current, and when the current is 0, we can get a maximum voltage drop across the VCE, which is nothing but the supply voltage VCC. So in this way we can get a linear or a straight line graph, which is known as the DC load line of a transistor. We will discuss it more deeply in our coming slide. So let us see. So we are discussing the DC load line of a transistor. So we first identify what is a DC load line is. It is a graphical representation or drawn between the collector current IC and the collector to emitter voltage VCE for a given VCC and RC. So it is the very important thing. It is nothing but a graphical drawn between the IC collector current and the collector to emitter voltage VCE. So it is all about the DC load line. To draw the DC load line of a transistor, we require VCE is taken on a x-axis, and IC, which is the collector current, is taken on the y-axis. So we have to take the VCE, that means the emitter to collector voltage, in x-axis, and IC, that means the collector current, in the y-axis of the graph. In this way, we are going to plot the DC load line for a transistor. How we can draw the DC load line? Only 2 points, cutoff point and the saturation points, are required. Line joining these 2 points is known as a load line, or the DC load line. So there are 2 points, cutoff point and the saturation point. These two are the main important thing. Determinations of cutoff point. First we determine the cutoff point. We have already discussed about it, so let us see more deeply about these equations. The output equations of a transistor is in common emitter configuration, which is CE mode, is given by the VCC equal to VCE plus IC RC. When the transistor is in cutoff state, so the IC equal to 0, that means there is no collector current flowing through the transistor, and the transistor is in off state, and it is due to happen when there is a no base current flowing on the transistor, and at that time the transistor is in off state, and the IC, that means the collector current, is 0, almost 0. So at that point we can get VCC equal to VCE, that means the whole supply voltage is came across the collector to emitter voltage. So it is the first case for the cutoff point, determination of cutoff point. In this way we can determine the cutoff point. Hence cutoff point is equal to VCE when the IC is 0. Determination of saturation point. In saturation, in case of the saturation of a transistor, the VCE of the transistor is 0, that is the maximum current flowing through the transistor, and hence at this time the VCC equal to IC RC. So the IC, we can find it out at VCC by RC. So in this way we can find out the saturation point, that means for VCE equal to 0 and the IC equal to VCC by RC. In this way we can find out the two different points. One is cutoff point and another is saturation point of the transistor. So if we plot these 2 points in a linear graph, which is in x-axis there is a VCE, that means the collector to emitter voltage, which is plot in the x-axis, and in the y-axis we are going to plot the IC, that means the collector current through the transistor. In this way we can, if I take the two extreme point, one is cutoff point, another is saturation point, there will be 2 points for CE, VCE. When the VCE is 0, we can get the maximum current, which is determined by VCC by RC, which is this point, which is known as saturation point. And another point is cutoff point, when the IC is 0, and we get the entire voltage as VCE equal to VCC, which is the supply voltage. At this point we can get the cutoff point and the IC is 0. So if I join these 2 points, we can get a DC load line of the transistor. So in this way we plot a DC load line of a transistor and determine how the DC load line will look like. So DC load line represents all possible DCs operating point of a transistor for a specified value of VCC and RC. That means the supply voltage and the resistance, collector resistance, or the load resistance, you can say. So in this way, the DC load lines is being plotted. The lower end of the DC load line is called the cutoff point. The upper end of the DC load line is known as the saturation point. The entire region between these 2 points, that means for the cutoff point and the saturation point, indicates the active region of the transistor. So it is the very important thing. The entire region between the 2 points, that means the cutoff point and the saturation point, is known as the active region of the transistor. The operating point, now we are going to come in the operating point. The zero signal value of IC and VCE are known as the operating point. This is called the operating point because the variations of IC take place about this point. It is also known as quotient point or the Q point, which is the operating point. Here you can see in the graph, it's very clear when these are the characteristics, output characteristics of a transistor, and it is the DC load line, whatever we discussed in the previous slides. In this way, at the point where the output characteristics of the transistors cuts this point, this is known as the quotient point or the Q point. So in this way, it is the major operating point of the transistor of an amplifier or any other cases when the transistor is in being operated. So let us discuss what is a AC load line. We have discussed the DC load line. There is a difference between the AC load line and the DC load line. DC load line is mainly when there is a no AC input signal is present, and AC load line is the AC load line gives the value of IC and VCC when there is an AC signal is applied to the base. That means if we discuss this, we just take an example for this picture. When there is no signal, if we just plot with the help of this DC voltages, we get a DC load line, and if we give input some AC signal to the base, and we can get a operating point of the DC load line with the help of this AC load line. So when the AC signal is being applied, at that time we can get the AC load line. So this is all about the load lines, and it is the load line play a very important role for the characteristics of an amplifier and the operating point of the transistor, and in this way the transistor operate as our desired level.
Thank you for watching. If you have any queries, you can contact to me. The contact number is given. The same number can be used as WhatsApp number. If you have any queries or doubt, you can call me or WhatsApp me to this number. Thank you very much.